Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing the natural number. So what is the natural number? Well, we call it E, and as it turns out it's produced by this equation, or this expression, and if you let n get very, very large, you get closer and closer to this, to the actual number. And the number, at least the first four digits, are 2.718. And again, it keeps on going out forever. And it's another type of irrational number, kind of like pi, and which is exactly why we like talking about it, because it has a lot of properties, just like pi has. Not the same properties that pi have, but it has special properties for logarithms and other things that make it very useful, and makes it very useful for things in the natural sciences. No pun intended with that. Let's actually do some basic calculations with this. So if we wanted to get an approximation for something like an expression of e squared, well, what we would have to do is we can just put into our calculator. Some calculators have the E button, which you can gladly go through and do these computations with. But we can substitute in like 2.718. We can square it, and then that'll give us a further estimation of 7.388. All right. So again, we just have to plug this into a calculator. Sometimes not everything has easy numbers. What about 4 times e to the negative 0.34? Well, it's 4 times, again, we can just plug in 2.718 as an approximation, and that's raised to the negative 0.34 power. Again, order of operations, we have to do the power first, so the exponent first, rather. 4 times 2.718 to the negative 0.34 is approximately, again, I put equal there, so it should be approximate, approximately 0.712. And then we have 4 times 0.712, which gives us exactly 2.848. All right. So we have these two decent approximations. Also with E, we can talk about the graph. And we would do, again, even though we have this nice just E there, rather than some number, it is not a variable, okay? And we can do exponential graphs just like we did previously. Again, E is 2.718, which is certainly bigger than 1, so we get our standard base graph out. So the base graph of e to the x. And with e to the x, that gives us the base point of 1e. So we have 0, 1, as always, and 1e. So e is about 2.7, so 1e, so about like here somewhere. We also have the horizontal asymptote, y equals 0, for our base graph. Again, we're not graphing this whole thing yet, we're just getting the base graph down. It's just e to the x. We have something like this. And what are the transformations we're going to have? Well, we have that's going to shift up 1. We also have a negative on the outside of the exponential, so that's going to reflect about the x-axis. We have a negative on the inside that we're multiplying by, so this is going to be a reflection about the y-axis. Okay, and what type of transformation do we do last? Well, we always do shifts last. So we're going to deal with these. And the reflections basically take our, for about the x-axis that flips over this, so we take our y values and we change them to negative y, and we get our x values because we have a reflection about the y-axis, so this way, about the x-axis. So we negate the x's and we negate the y's. So instead of 0, 1, it's going to be now, we just negate both terms, so 0, negative 1. Instead of 1e, it's going to be negative 1, negative e. Again, that's about negative 2.7. Probably could have put it further up. And then 0, negative 1, and then we still have the horizontal asymptote of y equals 0. Again, if we could, we'd apply that, but we don't. So we get this. And lastly, we're going to shift up, which means our y values are going to be put up by 1. So instead of 0, negative 1, it's going to be 0, 0. Our horizontal asymptote also gets 1 added to it. So instead of y equals 0, it's going to be y equals 1. Instead of negative 1e, it's going to be negative 1 about negative 1.7. So we're adding 1 to negative 2.7. So about negative 1, negative 1.7. And then we get our graph. And that's it. That concludes everything from this lecture and this section.